This is Tom again. Now we're going to use the Bisin, Clementi, Gottardi, my version of their baby's version, a complete markets version of their model to discuss the Modigliani Miller theorem. So here's the deal. We're going to allow a firm to issue both bonds and equity. And here's the deal. We have payoffs from issuing bonds are going to be, payoff from issuing equity are going to be the maximum either of zero, that's you get nothing, and that's bankruptcy state, or you get the payouts, the earnings of the firm exceed the bond obligations. If this earnings exceed bond obligations, that's the payout. For bonds, it's the other side. So 1 unit of the bond pays 1 unit of consumption good in state 1 if the earnings are enough to cover it, and that's going to be true as long as epsilon exceeds this threshold value, epsilon bar, and it pays. If it doesn't exceed it, it just pays all the earnings divided by the number of bonds that have been issued. So that's the deal. So these are the payouts from issuing from holding 1 unit of the bond that promises to pay B. It ends up only paying B if the firm is not bankrupt. If the firm is bankrupt, then you just get a share of the earnings. So the value of the firm, we have to recompute the value of the firm now. It's going to be the sum of equity, which is our V twiddle term, which we're going to have to recompute. And because now the firm's issuing bonds, plus B times the price of a bond of a firm that invests K physical capital and issues B bonds. So this price is going to depend on how many bonds the firm issues, because how many from the bonds issues affects its bankruptcy probability. So that's the value of the firm. Okay, and we're gonna continue to assume there's complete markets in Euro securities. And now the Modigliani Miller theorem, you could, it's related to the indeterminacy of portfolios argument that we made earlier as a property of the this model. Okay, so we can calculate both the value of equity, and we can calculate the pricing function, prices as a function of, it's important that this is little k. This is the k issued by a particular firm and with bonds. So we get this formula. So the price of a bond is, well, it's got 2 parts. It's all we're doing is we're going to integrate payouts of the firm to bondholders. If we're not bankrupt, that's this state, and each bond pays off 1 unit, so that's this. But sometimes the firm goes bankrupt, in which case the bondholders just get this amount right up here, which I've plugged in here. So that's the price of a bond. Price of the value of equity now is, the equity is only worth anything. I'm sorry. Equity holders only get something if epsilon turns out to be greater than epsilon star. So we only have to integrate. All I'm doing is I'm going to integrate this object up here over the set of non-bankruptcy states, and that's what I get here. And you might ask, why did I break this out into two parts instead of just put that integral, save myself some space here? I could have written this differently by this piece differently just by writing one integral and grouping those terms that I got from here. Would have made this more transparent maybe, but I didn't do it for a reason, because what I want to do is now to produce a Modigliani Miller theorem, I want to compute what the value of the firm is, the value of the firm. And remember, the initial owners of the firm, who are the consumers that own the firm, they want the firm to maximize its value. They want the firm to maximize this. So now the owners of the firm wanted to choose a K and a B in light of what this pricing function is that maximizes this total. And when the firm changes K and B, it's going to change both the value of equities through this formula, and it's going to change the price of bonds. So that looks complicated. So the firm, the owners want the firm to maximize this. That's key. And all the owners want that. So what we'll do is, we know equity is going to have to be evaluated like this. It's going to be affected by how many bonds you issue. The more bonds you issue, you're giving some of the payouts, some of the earnings to the bondholder. So the value of equity is going to go down. But the bondholders are going to get that value. So if we take B times this second term, multiplied by the price, and add it, we'll get the value of the firm. So here's the value of the firm. And what we'll notice here is the value of the firm, once we take into account how this pricing function reflects the amount of bonds outstanding, the value of the firm does not depend on how many bonds the firm issues. So let that sink in. B, this expression is going to turn out to be the same and determined only by the firm's optimal choice of capital, which we're going to assume it makes. And it doesn't depend on its choice of B. And this is all happening because the way the equity and the bond price respond to its choice of B. So that's what we got. So the Modigliani Miller theorem says the following. It says the value of the firm is independent of the mix of equity and bonds that it uses to finance its physical capital. So, so as I said, it doesn't matter. What's happening is, of course, look what's happening. Some subtle things are happening. When the firm issues more bonds, the price of bonds become riskier. The return on bonds become riskier. Equity becomes riskier too. The way things all work out is, and because of the complete markets, the consumers are able to make trades that the trades that consumers are making to support this in the background are kind of what's driving this. So the firm's decisions about how much physical capital to purchase don't depend on whether, and furthermore, so the firm's choice of whether to finance itself by issuing equity or bonds is indeterminate. And complete markets and Aero Securities is playing a big role in this. You can see this directly by the way those Aero Security prices, equilibrium Aero Security prices are depending in here. And these depend on the big K and the big C's in ways that we know. So what's going to happen is we've set this thing up with complete markets to start out set the stage for the paper that Bisin, Clementi, and Gottardi wrote with. And we have a separate quantecon lecture about that, where we're going to take exactly the same physical environment, but we're going to shut down markets and narrow securities. So we're going to shut down markets and narrow securities. And now all the firm can do to finance itself is by, can't sell arrow securities. People can't trade arrow securities. They can just trade bonds and equity. And what's going to happen is that's going to kill the Modigliani Miller theorem, the standard one. And we're going to kind of ask, how does it kill it, and what are the consequences of that? So when we visit that, we're going to be, you know, seeing some applications of Lucas's quote, his paraphrase of Tolstoy and Anna Karenina, that all complete markets models are alike. You know, they have standard components, but all incomplete markets models are incomplete in different ways. And Bisin, Clementi, and Gottardi made their model incomplete in a particular way. They shut down markets and narrow securities and left everything else the same. And we're going to study what happens. The remaining of this quantecon lecture is you're going to find code, and you know, it's code for computing an equilibrium, and the code looks a lot like the equations that we've written and gone through before. So I'll let you look at that on your own if you wish to. Thanks a lot.